My name is Emily Short, and this is my video for what I've enjoyed learning about most in sensation and perception. Originally, I believed that the thing I would enjoy learning about most was sound. However, I surprised myself in finding out the thing I loved learning about most was the perception of color. Now, the reason I enjoyed this most is because right after we had this lesson, I had the opportunity to take my children to the Fairbanks Museum, where we practiced making rainbows out of color prisms and different shades of light and how they're interpreted, or how we interpret them. And I was really excited to be able to share with my children just how this works. So I have a few pictures to share with you.
Light exists in waves, and its wavelength determines the color we perceive. For instance, short wavelengths give us blues, medium wavelengths result in greens, and long wavelengths produce reds. Together, these wavelengths form the visible spectrum, a small slice of the vast electromagnetic spectrum. When light reaches our eyes, it enters through the cornea, and it's focused by the lens into the retina at the back of the eye. Here we find two types of photoreceptor cells, rods and cones. Rods are highly sensitive to dim light but can't perceive color. Cones, on the other hand, are responsible for color vision and function best in bright light. We have three types of cones, each tuned to specific wavelengths. S cones for blue lights, M cones for green lights, and L cones for red lights. These cones work together to detect the light's wavelengths and signals them to the brain. Once these signals reach the brain, the real magic begins. The retina processes the raw information at first and sends it along the optic nerve to the visual cortex in the brain. Here, an incredible system called the opponent process theory comes into play. Our brain organizes color information into opposing pairs, red and green, blue and yellow, and black and white for light and dark contrasts. The system helps us to interpret a vast range of colors and shades with remarkable precision. Perhaps the most amazing part of color perception is color constancy. Even when the lighting changes, say from daylight to a dim room, the brain adjusts so we perceive the object's color as consistent. This is why a red apple still looks red even in the low grade of a candle. Another fascinating phenomena that we learned about during this process is color blindness, which it affects some people, making it difficult to distinguish between certain colors due to a deficiency in their cones. And we learned about after images, which occur when staring at a bright light for too long, causing the opposite color to appear when you look away. Ironically, this happened to me just a few days after I was decorating my house. The Christmas lights came on. I stared at them as I was putting them on the tree, blinked my eyes, looked away, and that's all I could see. It was very interesting to know the science behind my brain and why that was happening.
Well, now you know. I hope you enjoyed my video and had a wonderful and delightful Thanksgiving. Thank you.